Today we're going to start a new unit on right triangles. To start off, we're going to talk about the Pythagorean Theorem. But before we get to the Pythagorean Theorem, let's talk about what's called the triangle inequality theorem. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in this triangle ABC here, this theorem says that AB plus BC must be greater than AC. AC plus BC is greater than AB, and AB plus AC is greater than BC. Now let's talk about right triangles and the different parts of a right triangle. So we have two main parts in a right triangle. First we have a leg, so there are two legs, and these are the sides that are adjacent to the right angle. Then we also have the hypotenuse, which is the side that is opposite the right angle. Now in a right triangle, the hypotenuse is always going to be the longest side. Now the Pythagorean theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Now we have typically always written it as A and B are the legs and C is the hypotenuse. So then you can say that A squared plus B squared is equal to C squared. Now I'm going to write it a different way. I'm going to write it C squared is equal to A squared plus B squared. And the reason I'm going to write it this way is that it's going to help us later on when we're talking about triangles that are not right triangles. Let's take a look at some examples. Identify the unknown side as a leg or hypotenuse, then find the unknown side length of the right triangle. So in this first one, it looks like we have the hypotenuse, which is 5, and then we have two legs, x and 3. So the unknown side is a leg. Now, applying the Pythagorean theorem, we have 5 squared is equal to 3 squared plus x squared. So we have 25 equals 9 plus x squared, and solving for x, we have x squared equals 16, so x is equal to 4. In number 2, we have x as the hypotenuse that we're solving for, and then 4 and 6 are the legs. So we can write x squared is equal to 4 squared plus 6 squared, which gives us 16 plus 36, which is equal to 52. And now taking the square root, we have x is equal to the square root of 52. And if we want to put this in simplest terms without putting it in a decimal, because it does say to write your answer in simplest radical form, we can write 52 as a product of 4 and 13. And since 4 is a perfect square, we can take that out. So the square root of 4 is equal to 2. So this is equal to 2 root 13. Let's look at example 2. A 16-foot ladder rests against the side of the house, and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? Now, applying the Pythagorean theorem, we have 16 squared equals 4 squared plus x squared. So that's 256 equals 16 plus x squared. So x squared is equal to 240. Take the square root. And since our answer choices are in decimals, we can find the decimal approximation of the square root of 240, which is about 15.5. So our answer is going to be D, 15.5. Now you'll notice because this is a multiple choice question, you should be able to rule out answers. Now based on the information that you've learned so far, remember that in a right triangle, the hypotenuse is always the longest side. That means if there are any answer choices where x, one of the legs, is more than 16, we can rule out all those answer choices. In this case, we can actually rule out all of the answer choices other than D. Let's look at example 3. Find the length of the hypotenuse of the right triangle. So we have x being the hypotenuse, so x squared equals 24 squared plus 10 squared. 24 squared plus 10 squared is 576 plus 100, which is equal to 676. Take the square root and we get x is equal to 26. So the length of the hypotenuse of this right triangle is 26. Now we're going to talk about Pythagorean triples. A Pythagorean triple is a set of three positive integers that satisfy the Pythagorean theorem. Note that any multiple of Pythagorean triples will also work. Now here are some of the common Pythagorean triples. So 3, 4, 5. So 3 squared plus 4 squared is equal to 5 squared. 5, 12, 13. 5 squared plus 12 squared equals 13 squared. 8, 15, 17. 7, 24, 25. Now remember, any multiples of these will also work. So for example, 3, 4, 5. If you multiply everything by 2, you would have 6, 8, 10. So 6, 8, 10 is also a Pythagorean triple. So 6 squared plus 8 squared is equal to 10 squared. If you have these Pythagorean triples memorized, it will save you time. If, for example, you see anything on the SATs where you're in a timed circumstance and you want to be able to finish a problem faster, if you know these Pythagorean triples, it will make it much faster. Take a look at this first example. We have two legs, 9 and 12, and we have the hypotenuse as x. So, in terms of a Pythagorean triple, we're trying to find out what that third one would be, 9, 12, blank. Now we know that 9 and 12 are not themselves going to be part of a Pythagorean triple, but they could be a multiple of a Pythagorean triple. So it looks like here that both 9 and 12, as the legs, are just multiples of the 3, 4, 5 triangle. You just multiply by 3. Which means if we multiply 3 times 3 is 9, 4 times 3 is 12, that means 5 times 3 is 15. So the hypotenuse here is 15. Next we have 14 and 48 as our legs, and we're trying to determine what the hypotenuse is. So in this case, we're trying to see, okay, 14 and 48, we know those themselves are not part of a Pythagorean triple, but they could be a multiple of a Pythagorean triple. Well, 14 is 7 times 2, and 48 is 24 times 2, which means we can use the 7, 24, 25 triangle, Pythagorean triple, to determine the hypotenuse. So since I'm multiplying by 2, I can do 25 times 2, and that gives me that the hypotenuse is equal to 50. Now that we've talked about the Pythagorean theorem, let's talk about the converse of the Pythagorean theorem. So remember, the Pythagorean theorem said that if you have a right triangle, then the sides are related by c squared equals a squared plus b squared. The converse works the other way. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, so in other words, if c squared is equal to a squared plus b squared, then the triangle is a right triangle. Here's a diagram. So in this case, we're saying if you don't know that you have a right angle, but you look at the sides and you find that c squared is equal to a squared plus b squared, then you know that that triangle is a right triangle, and you know that the right angle is the one that is across from C. Let's look at example 5. Tell whether the given triangle is a right triangle. So let's let C represent the length of the longest side of the triangle. Now we don't know whether or not C is actually the hypotenuse because we're not told whether or not these are right triangles. But use the longest side because we know if it is a right triangle, the hypotenuse is going to be the longest side. Once you have that, now we can go ahead and check to see whether or not a squared plus b squared is equal to c squared. So in this case, we have 3 root 34, the whole thing squared, and we want to check whether or not that's equal to 9 squared plus 15 squared. I'm going to write a little question mark above the equal sign to remind myself that I'm checking whether or not this is the case. So 3 root 34, the whole thing squared, is equal to 3 squared, which is 9, and square root of 34 squared, which is 34, so 9 times 34. And we want to check if that's equal to 81 plus 225. 9 times 34 is 306, and 81 plus 225 is also equal to 306, so yes, this triangle is a right triangle. Now let's look at B. The longest side is 26, so I'm going to check to see if 26 squared is equal to 22 squared plus 14 squared. 26 squared is equal to 676. 22 squared is 484, and 14 squared is 196. Now we check. 484 plus 196 is equal to 680, which is not equal to 676. So we can say that this triangle is not a right triangle. Now let's talk about classifying triangles. So far up to this point, we've really only talked about right triangles. We use the Pythagorean theorem to classify a triangle as a right triangle. Now there are two related theorems that we can use to classify triangles as being either obtuse or acute. Remember that an obtuse triangle means that one of the angles is greater than 90 degrees, and an acute angle means that all of the angles are smaller than 90 degrees. Let's start with the acute triangle theorem. So the acute triangle theorem says that if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So in other words, if c squared is less than a squared plus b squared, we have an acute triangle. Now remember, c is always going to be the longest side. It does not necessarily mean that you have a hypotenuse. We always use the longest side as c, and if that longest side squared is smaller than the sum of the other two sides squared, then you know you have an acute triangle. On the other hand, the obtuse triangle theorem says that if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. So if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. Again, c is always going to be the longest side. Let's take a look at example 6. Can segments with lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? If so, would the triangle be acute, right, or obtuse? So, for the first step, we're going to use the triangle inequality theorem to check that the segments can actually make a triangle. Now, this was the very first theorem we talked about, and we said that any two sides added together should always be greater than the third side. So let's check. 4.3 plus 5.2 is 9.5, which is greater than 6.1. 4.3 plus 6.1 is 10.4, which is greater than 5.2. And 5.2 plus 6.1 is 11.3, which is greater than 4.3. So now that we've checked, using the triangle inequality theorem, we can say that these sides can form a triangle. Next step, we're going to classify the triangle by comparing the square of the length of the longest side with the sum of the squares of the lengths of the shorter sides. In other words, we're going to compare c squared with a squared plus b squared. Let's go ahead and substitute. Remember that c is always going to be the longest side. In this case, that would be 6.1. So we have 6.1 squared compared with 4.3 squared and 5.2 squared. Simplifying that, we have 37.21 and 18.49 plus 27.04. Adding the right-hand side, we have 45.53. Comparing those two, c squared seems to be less than a squared plus b squared, And so that means that these three side lengths form an acute triangle because c squared is less than a squared plus b squared. So today we not only talked about the Pythagorean theorem and how it applies to right triangles, but we talked about some additional theorems on how you can determine whether or not a triangle is a right triangle using the Pythagorean theorem. We also talked about how we can use the acute and the obtuse triangle theorems, which are related but not exactly the same as the Pythagorean theorem. So we'd compare c squared with a squared plus b squared, and that can help us determine whether or not we have an acute triangle, so if c squared is smaller than a squared plus b squared, or if we have an obtuse triangle, if c squared is greater than a squared plus b squared.